So here we'll be discussing terms used in helical spring or compression spring. Okay, this is a compression spring or helical spring generally we call. So first definition is solid length. First definition is solid length. When the compression spring or helical spring, when the compression spring is compressed until the coil comes in contact with each other. So then with each other, then the spring is said to be solid. What is solid length? For example, whatever here we have the spring, if that is compressed like this, if that is compressed like this, then they come in contact with each other. They come in contact with each other. Then that spring is said to be solid. Then if you measure the length, then that's going to be solid length. What is solid length? When the spring is completely compressed, all the coils come in contact each other. Then if you measure that one, then if you measure the length of that, then that is called as solid length. Solid length can be measured like this. I dash is total number of turns, total number of coils. You can one coil, two coil, three coil, four coil, five coil, six coil, like this. Okay. Then D is diameter of the spring wire. This spring is though whatever it is wounded, spring is wounded. This is made by when you wire. This is made by wire. When you elongate it, it becomes a wire. So D is diameter of this wire. N is number of coils. So totally solid length equal to product of number of coils into diameter of the wire. So we know the solid length. When all the coils are compressed, then that's called as solid length. Now we will be discussing about the free length. Now we will be discussing about the free length. The free length of a compression spring is the length of the spring in the free or unloaded condition. Unloaded condition. For example, spring has no, it is completely left free. Then whatever the length we get, for example, here it is a free length of the spring. So when the coil is not at all applied a load, it is freely kept. Then if you measure the length of that one, then that is called free length. Free length formula is here. A is clearance. I is number of active coils, number of coils. Oh, you can count the number of 1, 2, 3, 4, 5, 6. Actually, number of active coils. We will be discussing about the active coils in future classes. Now, just say I is number of coils, Y is maximum deflection. So, how much we can elongate that one? D is diameter of the wire. So, total free length can be calculated by using this formula. This formula also we use in problems. So, free length is the length of the spring when that is completely unloaded. Now we have the one more definition that is called spring index. Now new definition what we have, that is called spring index. What is spring index? The spring index is defined as, the spring is defined as ratio of mean diameter of the ratio of mean diameter of the coil to the diameter of wire. So once again I am telling you, once again I am telling what is spring index. Spring index is the ratio of mean diameter of the coil to the diameter of wire. So you can look it into this picture. So this where I am marking here, this is the mean diameter of the spring. Then this D is diameter of the, small d is diameter of the wire. This capital D is diameter of the spring. Okay. Small d is diameter of the wire. Then ratio of spring diameter to the wire diameter is called spring index. So D is mean diameter of the coil. Coil is nothing but spring. So D is diameter of the wire. Now, next definition is spring rate. The spring rate is defined as load required per unit deflection. Spring rate is defined as load required per unit deflection of the spring, which means, so for example, spring is here, we are applying some load. Okay. So what load it is required? What load it is required so that spring can deflect 1 meter or 1 millimeter. So unit deflection length will be there. So what I'm telling you, spring rate is a load required to deflect unit deflection, which means for let's consider one spring is there. To deflect that, to elongate that, or to compress that for 1 meter, how much force to be applied, then that is called spring rate. So spring rate is can be written like this: F by Y. Y is deflection of the spring, F is applied load. This spring rate also called as stiffness. Spring rate is also called as stiffness. Once again, stiffness is load applied by deflection. Load applied by deflection is called spring rate. Now, what we have pitch. Next definition is pitch. What is pitch? The pitch of the coil. The pitch of the coil is nothing but spring. The pitch of the coil is defined as axial distance between adjacent coils of adjacent coils in uncompressed state. Let's say consider spring here. Spring is not at all applied with any load. Then whatever the gap we have in between the two coils, let's two coils, adjacent coils. So let's this point consider this point of next coil. So whatever the gap we have here, that is called pitch. Pitch is the pitch of the coil is defined as it is a axial distance. Axial andre this is the axis of the spring. So we need to measure along the axis in the axis direction. So once again, the pitch of the coil is defined as a axial distance between adjacent coils in uncompressed state. So which means no load is applied. Thank you for listening.